Hi everyone. Today the topic is Chemical Engineering Gate 2021 paper. So the questions here are question number 1, 33 and 43. So these questions we are going to solve today. So a double effect evaporator is used to concentrate a solution. Steam is sent to the first effect at 110 degrees centigrade and the boiling point of the solution in the second effect evaporator is 63.3 degrees centigrade. The overall heat transfer coefficient in the first effect and second effect are 2000 watt per meter square Kelvin and 1500 watt per meter square Kelvin respectively. The heat required to rise the temperature of the feed to the boiling point can be neglected. The heat flux in the two evaporators can be assumed to be equal. The temperature at which the solution boils in the first effect should be found out in degrees centigrade. So this is the question number 1 in GATE 2021 technical section. So now we are going to consider the solution. So given U1 is 2000 watt per meter square Kelvin, U2 is 1000 watt per meter square Kelvin. So already it's mentioned in the question that Q1 is equal to Q2. Then we consider the heat transfer formula, that is a Q is equal to UA delta T. So this is the representation of the two evaporators. So this is the first and second evaporators and the temperatures are given and the volumes are being mentioned. Then here we consider from the above equation Q by A is equal to Q, which is equal to U delta T. As already Q1 is equal to Q2, U1 delta T1 is equal to U2 delta T2. So substituting the terms, U1 is 2000 into Ts minus T1, which is equal to 1500 into T1 minus T2. So here 2000 into 110 minus T1, which is equal to 1500 into T1 minus 63.3. Now multiplying the equation becomes 440 minus 41, which is equal to 3T1 minus 189. So solving this equation, we get 7T1 is equal to 629.9. So from this, T1 becomes equal to 89.98 degree centigrade. So already the terms are mentioned in the equation. So here we can see the temperature of the solution in the first effect evaporator is find out as 89.98 degrees centigrade. It's almost 90 degrees centigrade. So in this way we can solve the question of double effect evaporator. So next question is, for a shell and tube heat exchanger, the overall heat transfer coefficient is calculated as 250 watt per meter square Kelvin for a specific process condition. So here it's given overall heat transfer coefficient is 250 watt per meter square Kelvin. It is expected that the heat exchanger may be fouled during the operation and a fouling resistance of 0.001 watt per meter square Kelvin is prescribed. Similarly, the dirt overall heat transfer coefficient should be found out. So here we have mentioned the overall heat transfer coefficient and it has also been given the fouling resistance is been mentioned as 0.001. So U clean is 250 watt per meter square Kelvin and RF, that is a fouling resistance, is 0.001 meter square Kelvin per watt. So now we have to find out the dirt overall heat transfer coefficient. So considering the formula for this problem, 1 by U dirt is equal to 1 by U clean plus RF. So from this, we can substitute the values in this equation. On solving, we get 1 by U dirt is equal to 1 by 250 plus 0.001, which is equal to 0.005. So now from this U dirt becomes equal to 200 watt meter square Kelvin. So 200 watt per meter square Kelvin is the answer. So it's a simple problem. So just for the shell and tube heat exchanger is given. From this heat transfer coefficient is given and falling resistance is given. You have to find out the dirt overall heat transfer coefficient. So from the equation we have solved that dirt overall heat transfer coefficient is 200 watt per meter square Kelvin. Similarly, next question is, in a double pipe heat exchanger of 10 meter length, a hot fluid flows in the annulus and a cold fluid flows in the inner pipe. So here we have to consider a double pipe heat exchanger which has a hot fluid and cold fluid. So hot fluid flows in the annulus, that is between the pipes, and a cold fluid flows in the inner pipe. In the inside pipe, the cold fluid will be flowing. So the temperature profiles of the hot fluid TH and cold fluid TC along the length of the heat exchanger is given by the equations. TH of x is equal to 80 minus 3x, TC of x is equal to 20 plus 2x. So the length is mentioned as 10 meters. So here TH and TC are in degrees centigrade and x is in meters. Now we have to find out the logarithmic mean temperature difference in degrees centigrade. So this is question number 43 in GATE 2021 paper. Now solving this, so already given the equations as TH of x is equal to 80 minus 3x, TC of x is 20 plus 2x. So for hot fluid, so initially we consider starting from the 0. So TH of 0 becomes equal to 80 minus 3 into 0, which is equal to 80. Similarly, at 10 degrees centigrade, TH of 10 becomes equal to 80 minus 3 into 10, which is equal to 50. Similarly, for cold fluid, TC of 0 is 20. TC of 10, that means at 10 degrees centigrade, it is 20 plus 2 into 10, which is equal to 40. So now calculating delta T1, which is equal to TH of 0 minus TC of 0, which is 60. Similarly, delta T2 is TH of 10 minus TC of 10, which is equal to 50 minus 40, that is 10. Now, considering the formula, we get LMTD is equal to, so logarithmic mean temperature difference is equal to delta T1 minus delta T2 by ln delta of T1 by delta T2. So substituting the above terms in this equation, we get 60 minus 10 by ln 60 by 10. So solving this, we get the answer as 27.9. So we have determined the LMTD, which has been asked, the logarithmic mean temperature difference in degrees centigrade. So these are the theory questions related to heat transfer. So if you like my description, please subscribe my channel. Please like, share and comment my videos. Please click the bell button to get the notifications for the new videos. Thank you very much.